Okay, class, picking up where we left off at, we're at our next example. It says, from a group of 40 students in the class, 35 took the test, 9 got an A, 12 got a B, 11 got a C, 2 got a D, and 1 got an F. Draw a Venn diagram for this problem. Solution. All the sets are disjoint. No student can receive 2 different grades, which was shown here. This is basically the Venn diagram you would draw for all of these grades. You cannot get 2 different grades for one card marking out of the same class. Okay, now we have an example. The next example, it says, from a group of 55 students enrolled in college, the following numbers of students are enrolled in developmental courses. English, math, and reading, 25 are enrolled in English, 20 are in math class, and 25 are in reading. 4 are in both English and math. 7 are in both math and reading. 10 are in both English and reading, and 3 are enrolled in all 3 courses. Now we want to draw a Venn diagram for this problem. Then determine how many students are enrolled in only one class. Now as you see, we have the Venn diagram provided for us. Now we are going to get into drawing the Venn diagrams ourselves, but right now we have this diagram here. It says, number 1, start filling the diagram from the innermost regions, intersection of all 3 sets, students enrolled in all 3 classes. Okay, if you notice, it's only 3 students that are enrolled in all 3. So we're told to start here. It says, next fill up the leftover intersections of the sets. There are 4 students enrolled only in math and reading. So we have math and reading, and we have 4. We have 1 student that is enrolled, well actually we have 4 students that are enrolled in math and English. So, and we also have 7, well actually it's still 4 that's in math and reading. We have a total of, wow, we have a total of a lot of students. We have 18, 25 students that are in reading, and it may overlap with other areas. And then here with English, we have, 25, and even though it overlaps with other areas. And then math, we have 20 in math. And if you notice, we have 3 that's on the outside that's neither in reading, English, or math. Okay, now, and it just gives us some other general directions of how to fill in the Venn diagram. You can read that at your leisure. But let's go on to this next example. It says here, determine how many students are enrolled in only one class. Okay, this is still part of the previous example. It says there are 11 plus 14 plus 12, which is 37 students enrolled only in one of the mentioned developmental courses. If we go back here, we're just talking about all of the numbers that do not overlap, which is just 12, 11, and 14. So that's how we get the 37. Now, we go down here to our next example. It says here, let U or the universe equal to, and you see we have numbers 1 through 15. And then we have it broken down with A being 1, 3, 5, 7, 9, 11, 13, and 15. All of the odd numbers from 1 to 15. Then we have 3, 6, 9, 12. We have multiples of 3 for 15. And then we start with 6 and end up with 15 for C. Now we want to draw this Venn diagram. So we know that this U will be our universe. We have one set that's A, one set B, and the last set C. Now again, we want to go through this systematically. We want to go through and start with what intersects with A, B, and C. Now what you can see that intersects with all 3 is the number 9 and 15. If you look here, the number 9 and 15 is in all 3. So we will put 9 and 15 here, because that intersects all 3. Now, we come to the next number. Let's just go with the A here. What intersects with A and C? if you look here with A and C, you have the numbers 7, 11, and 13. 7, 11, and 13. That intersects with A and C. So we have 7, 11, 13. Now let's do with B and C, or B and A. We could do B and A. If you notice with B and A, the only thing they have in common is 3. Now we go here to B and C. B and C has 6 and 12. So we will put 6 and 12. Now that takes care of all of the intersections. Now we look at the numbers that are just exclusive to A, B, and C, which is 1 and 5 for A. It's non-exclusive to B, but 8, 10, and 14 is exclusive to C. And the two numbers that are left out are 2 and 4 that will go here in the universe, the universal set. Now it says, from the Venn diagram, determine the cardinality of the following sets. So now, this is what we would do. We had A intersect B intersect C. So now, we want where all of the numbers intersect at for all three regions, A, B, and C, which is 9 and 15. So this is equal to the set of 9, 15. Those are the only numbers that are in all three sets. So the cardinality is 2, because they only had 2 sets of numbers. Now we go here to A intersect B. Now first of all, we'll deal with A intersect B, which would give us where A and B intersect. They only intersect at 3, 9, and 15. So we would draw our set of 3, 9, and 15. Now we want to intersect that with the complement of C. So that means everything that is not in C. So now we will go with that. We have 1, 2, 3, 4, and also 5. But everything else is in C. So now we look at what they have in common, because this is intersection. So they only have the number 3 in common. So this set is just 3. Its cardinality is 1. So the final answer there is 1. They have one element in common. Now we go here to A intersect B. Now what we could do is this here. Instead of, well, I guess we can still just draw out the set names. Okay, so now we look here. If we look at A, we have the following numbers in A. We have 1, 5, 3, 9, 15, 7, 11, and 13. Now my thing is this here. Instead of, I'm going to go with what I was about to say earlier. Instead of writing out all those numbers, let's just see where A and B intersect at. They intersect at 3, 9, and 15. So A intersect B is 3, 9, and 15, which means that's 3. They had 3 elements. Now we come here. We have A intersect C. Now we look here. A intersect C is these numbers here. 7, 11, 13, 9, and 15. Now we want this to intersect non-B or B complement. And the only numbers of these that are not in B is 7, 11, and 13. So it'll be 7, 11, and 13, which will give us a cardinal number of 3. Now, we scroll down, and I took the liberty of drawing this Venn diagram again, because we still have a few more questions to answer, and then we'll be done. Okay, now we got C is intersect to B. Okay, so now C intersects B. So we go here where C and B intersects at. If you notice, they intersect here at 9, 15, 6, and 12. So it'll be, we will have, well, let's put it 6, 9, 12, and 15. So they intersect at 6, 9, 12, and 15. So its cardinal set is 4. Now we come here, we have B intersect C. Now B intersects C, we will go here. B intersects C at basically what we had here for C, 9, 15, 6, and 12. Now we want to intersect that with 9A. So that would take off the 9 and 15 and just leave us 6 and 12. And its cardinal set would be 2. Now we scroll down here to D and H. Now let me see if I can show this figure. Okay. Now we had A intersect C. Now if we look here, A intersect C are all of these elements here. We have 7, 11, 13, 9, and 15. I know they're out of order, but we have all of the elements here. So we have 5 elements, so the cardinal number is 5. Now we go to H. Now we have A union B union C complement. That means we know with union, that means that would include all of these elements. We just wouldn't count them twice. So A union B union C, that's all of these numbers here. And we want the complement of that, which would be these numbers here, which is 2 and 4. 2 and 4 are the only numbers that are not in A, B, or C. So that cardinal set is 2. And we're done with this section.